Alright. Assalamualaikum. My name is Syed Amirul Hanif Bin Syed Hassan, and I would like to talk about my final year project, which is investigating the performance of dynamo-based motor for self-charging system. Okay, we move to the next slide. The use of smartphone in this day is become the basis of the daily life. Involving technology makes various sector of the economy, including the food delivery system. To ensure that the deliveries rider is always in touch with the client, they must always be prepared with the adequate battery supply. So the use of dynamo-based motor for the self-charging is useful and alternative that should be given attention. In this project, two types of dynamo-based motor on the performance of self-charging system will be studied. Okay. The energy cannot be created or destroyed. Okay. But it may be transformed to several forms. A fresh alternative can be created by using a dynamo or a DC generator to guarantee that energy flow on its own, which is a DC motor converts mechanical energy into the electrical energy. So it is vital to use an Arduino microcontroller to analyze device charging rate in order to avoid overcurrent and acquire result from the circuit using the Internet of Things, which is IoT. So the important component that required to use in this project are LM2596 voltage regulator module, voltage sensor module 25 volt, ESP8266 Wi-Fi transceiver module, and a DC motor 775 high speed high torque 12 volt. Okay. For the literature review, there are some articles and journal that I found to acknowledge and inspired by the previous researcher. Firstly, we talk about the mechanical power generation. Okay, the mechanical energy is converted to electrical energy by generators. Okay, which may subsequently be used to power electronics in the circuit. So the term generator is often used in the wide sense to describe the number of device, okay, that employs magnet and wire coils to create electricity. So in all generator, there is permanent magnets or electromagnets, as well as a wire coil armature, which is employed. So depending on the generator, these two components can be installed in one of two ways. Okay. So secondly, the bicycle dynamo electricity production. All right. Dynamo were created as a battery substitute. The commutator is, in essence, a rotary switch. So, it is made up of a series of contacts that are positioned on the machine's shaft. So, each dynamo can generate 24 volt, which may be utilized for power application. So, a common bike generator has power output of 100 watts, mainly 100 watts, average 100 watts. So, if a user cycle for an hour, uh, every day for 30 days, the user will have 3000 watt per 3000 watt hour, which is 3 kilowatt per hour. So most by Dynamos produce 3 watt, which highest power version producing about 6 watt. I think 6 watt. So the third part is the voltage regulator. So the voltage regulator are also employed in electrical device where high voltage fluctuation might be hazardous. So voltage regulator is any electrical or electronic device that keeps a power source voltage within acceptable limits. So the voltage regulator function is to keep the voltage within tolerance range of the electrical equipment that utilize that voltage. Okay. So next, we go to the problem segment. The delivery riders are mostly on the road in the whole day, so they must have an adequate battery supply. By using a dynamo-based motor for self-charging can help delivery riders to save up the battery and recharge their smartphone. So by using Arduino microcontroller, the performance for dynamo-based self-charging can be observed. Alright. So for the objective is to develop a self-charging system using JC generator and Arduino microcontroller. So second is to observe the consistency of voltage input using voltage regulator, and to calculate the power of the GC generator produced by using Internet of Things device, and also to analyze the charging rates of the device that being charged by using DC generator. Okay. The scope is to create a dynamo-based motor or DC generation system that converts to self-charging and receives results, while the limitation is sensitivity of the sensor may be modified by the surrounding. Okay. Okay, for the methodology, the initial stage, is to acquire all essential information on selected topics, followed by in-depth study. In this involve looking into current research paper, articles, journal, and books on topics including the IoT, DC motor generation, and also the performance of the self-charging system itself. Okay. So before we write the coding, we will implement the software for the coding and compile the written source code. If the problem is found during the compilation, we will rewrite the code before it's move on to hardware development. So each component and module will be tested individually with an Arduino Uno. And if it's working, and we will achieve the goals. So for the expected result is from this project is to ensure that the user receive notification and able to monitor the self charging rates via smartphone. The connection between the Arduino and microcontroller and the Blink application should be established and capable to give access to the user. This is the circuit and the list of the components. Okay. This is the application that will be used for Internet of Things, which is Blink application. features for self-charging performance result. Okay. This is the coding for using in this project. This is the coding for voltage, which is voltage multimeter, like something like that. And this is the expected result, which is to check the voltage using serial monitor, the input voltage. Which okay. Next is testing for our my project to charge the power bank. Okay, as you can see, there is the blue light for the power bank is charged. Okay, that's all. Thank you.